Hi everybody, welcome back to Chapter 6, Algebra. This is Section 6.6, Systems of Inequalities. We are going to graph some inequalities. If you remember, we've done a lot with inequalities, we've done a lot with graphing, we've done a lot with systems. So we're kind of just putting everything together at this point. So a system of inequalities looks a lot like a system of equations, except it's got less thans, greater thans, less than or equal to, or greater than or equal to's. Two or more variables, two or more inequalities. So when we go to solve a system of inequalities, this is where it's kind of interesting. It's all the ordered pairs that satisfy both of them. So in other words, if I pick a point and I put it into the inequality, I have to get a true statement when I do the math on both of my inequalities, not just one. So it's all ordered pairs. It's kind of a fuzzy answer. There isn't anything specific you can write on the answer line on a quiz or a test or homework, because all we can do is look for everything that satisfies both of them. The easiest way to graph, of course, everybody knows at this point, is to put it in mx plus b form. Easy to find the y-intercept, the slope, and then go ahead and sketch that graph. So when I give you a system, I'm going to give you two inequalities, and you're going to graph them both on the same coordinate plane. It could get messy because remember, for inequalities, we do shading. So you're going to look to see if you're using a solid or a dashed line when you sketch each one separately. And you're going to shade each inequality using that test point. Everybody's favorite or easiest test point is always going to be the origin. Remember, the only time you can't use 0, 0 is if your line, your equation, touches the origin. You can't use it. It doesn't give you enough information. It's not precise enough. And here's the interesting part. Again, no one answer for the line, because the answer or the solution is the entire part of the graph that is shaded by both inequalities. So we're going to sketch an inequality and shade it. We're going to sketch the other inequality and shade it. And then we're going to look to see where is it double shaded. So let's do an example or two. First example, nice and neat. Both of these inequalities are in mx plus b form. So we can just get right to it. There's no pre-graphing work needed. So let's do each inequality separately. I do everything because otherwise it starts to get confusing. So for the first problem, let's put a little line here so we can keep track. There's three things that I always look for. One is the y-intercept, which is 1. One is the slope, which in this case is -1. Or if you like that fraction to remind you about rise over run, -1 over 1. And then should we use a dashed or a solid line when we sketch this? I'm going for dashed because it doesn't have the or equal to. Plenty of information. We can get this on the graph. So b is 1. The slope is down 1 and right 1. And I always ask, if you run out of room, you could go up 1 and left 1. We're going to connect those with a dashed line. Make it a nice and long dashed line. Don't forget your arrows at either end. And before we walk away from this particular part of our system, we need to make sure we shade. We can use 0, 0 right in the middle of the graph because my graph does not go through the origin. So when I put a 0 in for x and a 0 in for y, I've got 0 is less than 1 when I do the math, and I would agree that's a true statement. So since it's true 0, 0, I'm going to put that in the shaded part. These look really nice when you use colored pencils or highlighters and shade them, and then you can see that double shaded part when we get the second one on there. So the second inequality, y is less than or equal to 2x plus 3, it's ready to go. It's an mx plus b form. So I'm going to ask you those same questions. Y-intercept, 3. Slope is 2, or 2 over 1 if you like rise over run to help you remember. And this time, dashed or solid line, we're going to go with the solid because it is less than or equal to. Remember, or equal to is your keyword for a solid. So I'm going to start with my slope at 1, 2, 3. I'm going to do my, that was my b at 3. My slope is up 2 over 1. And of course, I could go down 2 and left 1. I'm going to connect those with a line. Use a ruler. My line isn't very good. I'm a little off on that. There we go. And I'm going to do a little test point because remember, we're not done until we finish shading and we're looking for the double shaded part. So 0, 0 would be a good point to test for this one again. So when I put a 0 in for x and a 0 in for y, I've got 0 is less than or equal to 3. I would agree. 0 is less than or equal to 3. So remember, I'm looking at the green line, so I'm looking to see if I'm going to go in the upper left or the lower right. Well, 0, 0 is in the lower right, so I'm going to shade this portion of that graph. So you got to kind of just ignore the other line and the other shaded portion and get that one taken care of. And last but not least, make sure that we can see really clearly what is the double shaded part. Go back, make that one a little bit darker, or shade over it a little bit more. But it looks to me like this section down here that is primarily in quadrants 3 and 4 is where our double shading happens. So that's the solution. Any point in that double shaded part is a solution, gives both of the inequalities a true statement. So we got 0, 0 was true in both of those. So 0, 0 is one of the many solutions possible for that system. But I could also say a point like negative 3, 2. Negative 3, 2 is also a solution because it's in the double shaded part. And if I put negative 3 in for x and 2 in for y in both of those inequalities and did the math, I would get a true statement for both of those. So any point that I choose in the double shaded area will give me a true statement for both inequalities. It's kind of an and situation. Both inequalities have to be true. The first and the second are true. So let's do another system. This one, if you notice, is not in mx plus b form. So we're going to have to do a little bit of work here. So I'm going to just take the first one. Let me make a little line here. So I've got an x minus y is less than negative 1. I always leave the y where it is and get rid of the other stuff, so negative x. Please notice when I subtract x from both sides, I'm not left with just a y, I'm left with a negative y. I've got a minus x and a negative 1. So I never am really interested in what negative y is. I'm going to divide everything by negative 1 because that way now I've got a positive y. When I divide, I end up with positive x and a plus 1. And I didn't put that inequality in there because I'm hoping that you're shouting at me telling me, since you divided by negative 1, you have to flip your inequality over, and now it's going to become a greater than. So now we've got enough information for our y-intercept and our slope. Y-intercept is 1, slope is 1, and again, I always ask, am I going to use a dashed or a solid line? And I know I've got myself a dashed. So b is 1, slope is up 1 and right 1, down 1 and left 1 if you prefer. Use your dashed line to connect them. And let's do ourselves a little test for 0, 0. So when I put a 0 in for x and a 0 in for y, I get 0 is greater than 1. I absolutely positively disagree with that statement. Since 0, 0 gave me a false, I'm going to go to the other side, the upper left half of that graph for my shading. I'm going to do exactly the same thing for my x minus y is greater than 3. I'm going to start by subtracting x. So negative y is greater than negative x. And that 3 is a plus since it didn't tell us it was a minus. I'm going to divide everything by negative 1 because I'm not really interested in negative y. And I get y, I get an x, positive x, and a minus 3. And now, again, I hope you're shouting saying you divided by negative 1, don't forget to flip that over and make it a less than. So all the same rules apply for inequalities. So the b for this one, the slope and dashed are solid. B would be negative 3. The slope would be 1 or 1 over 1. And this one's going to be a dashed as well. It doesn't matter, you just do what it tells you to do. So my slope this time is negative 3, 1, 2, 3. Sorry, my b, my y-intercept is negative 3. My slope is positive 1. What do you notice as I'm doing my positive 1 slope on this and connecting them with a dashed line? Are you noticing that these are parallel, these two lines? So we're just going to look at our shading. Doesn't make a difference, but I didn't draw my lines very well, but it is parallel. I can still test 0, 0 on this because 0, 0 is on the top part. My line doesn't go through it. So if I put a 0 in for x and a 0 in for y, I get 0 is less than -3. 100% disagree with that. That is a false statement. 0 is not less than 3. So I know I'm going to shade on the other side. That means I'm going for the light blue line over here to the lower right. So this one's interesting because where's my double shaded part? Where will these two both overlap in the shading? I'm not seeing anywhere, right? If my green and my blue line are parallel and the shading's on opposite sides, I'm going to have to say this is a big old no solution. There is no ordered pair in the whole wide world to infinity and beyond that will make both of those inequalities true. So that's a big no solution. Doesn't happen very often, but every now and then. I have two more examples for you. If you look at number 3, those are both in mx plus b form. They do have a double shaded portion. Feel free to go ahead and do that. And number 4, same thing. It's an mx plus b form. I don't know why I didn't make them a little bit trickier for you, but go ahead and do those. I would actually save this graph for number 4 so that you can do it for the practice problem. I forgot to give you some graph paper on that. So lesson summary, here's what we want you to write in this box down here or near it. What's the most difficult part of graphing systems of inequalities? What's the trickiest part or the most difficult part? Tell me something. If everything's super easy, tell me something that you can foresee that somebody else might get tricked by. Maybe it's that -y thing. Maybe it's putting it in mx plus b form. Maybe it's knowing where to shade. Maybe it's knowing if it's a dashed or a solid line. What's the most difficult or trickiest part of graphing systems of inequalities? And we'd like you to go ahead and do this inequality system. Y is greater than or equal to x minus 1. Nice and neat, right? That's already in mx plus b form. The other one is a 1/2 x plus y is less than 2. That one's not in mx plus b form, but if you just do one step, get the x, the 1/2 x out of there, it will be, and you'll be able to identify your slope and your b. Please notice in that second inequality, your slope will end up being negative, so your line will be sloping downward. Go ahead and get that done. Have a wonderful day.